Hello students, in this video we will talk about the concept of analysis of variance. Analysis of variance is used for the equality or testing the equality of more than two means. That is, we are interested in comparing the mean values of the three groups. This is when we apply or use analysis of variance. So what I have done, I have taken an example from the book in which we have drawn or we are given two samples or two sample data sets drawn from two different populations. And when the sample mean values were computed for the two data sets, it is found that x1 bar, which is the sample mean obtained from the first data, is equal to 20 and x2 bar comes up as 25. But if we observe the spread with respect to the mean values obtained for both the data sets, we can see that there is an overlapping scenario that exists between the two data sets. The sample mean or the sample data that has a mean value of 20 has a representation for of the values greater than 20 as well. Similarly, for the second data set, which has a mean value of 25, we can easily observe that data also contain the values below the mean value of 25. So this zone of the second data is overlapping with this zone of values of the first data, whereas this zone of first data, which has a lower mean value, is overlapping with this zone of this data, second data. Now, if we look at another data set that has the similar findings, that is x1 bar is equal to 20 and x2 bar is equal to 25. Over here you can clearly see that the data that has the mean value of 20 has all the values concentrated towards its mean value, whereas the data set 2, which has the sample mean value of 25, is concentrated entirely towards its mean value. And there is a line of division that we can observe easily, for instance, at 22. So this line is dividing the two data sets at two different positions. So when the entire data is concentrated closer to the mean value, does indicate that it has a very small standard deviation value. So in the second scenario, which is this one, both the data set have very smaller standard deviation values. Whereas if we look at the first situation, over here spread of the two data sets is greater or higher relatively. And therefore, we can say that standard deviation of these two data sets are relatively higher or greater. If we want to draw the conclusion about the difference between the two population means, first situation is ambiguous because this has an overlap between the two data sets if we compare. And it is because of the fact that their standard deviations are higher or greater relatively. But if we focus with the same perspective on the second situation, over here standard deviation values are very low. Therefore, the entire data is concentrated towards the mean values. And since the standard deviation is low, therefore there is no chance for overlap between the two data sets. And therefore we can draw in the second situation this conclusion easily that population mean mu1 is less than that of population mean mu2. Whereas we cannot draw this conclusion in the second situation. Now looking at another measure of dispersion or graphical depiction of another measure of dispersion, that is interquartile range, with the help of the box plot. The box plot, we all know that are based upon five number assembly. That five number assembly is minimum, lower quartile, median, upper quartile, and maximum. If we look again at the first scenario, so the least position is of the second data set as far as its median is concerned. Center line of the box is the median line. And this difference of the box is in fact loop between the region or the zone or the range between Q1 and Q3 we call the interquartile range. So interquartile ranges in all three data sets are smaller over here. That's again the measure of dispersion when we look at the behavior of the data with the help of box plot. So median line, if we extend outside the box or the first box, this is not overlapping in any other box. Similarly, if we extend this center line of the second box, it will not overlap in any other box, and same is the situation with the center line of the third box. And this is possible because these three data sets have lower values for interquartile ranges. Therefore, there is a rare chance that the center line of each box will overlap with any other box. If we see this, look at this one second scenario in which the order is same. The second box plot is at the least position because its median is at the least position. Next higher is this one and the highest is this one. Now we extend the center line of the first box. It will clearly overlap in second box as well as in the third box. If we extend this one, same situation exists for the second one as well. And if we extend the central line of the third box, the scenario is same. It will overlap both in the other two boxes. Therefore, if we want to draw the conclusion about their median relationships in the context of the population, so x1, x2 curve is least, x2, x1 curve is the next higher, and x3 curve, that is the notation for the median of sample, is at the highest position. Same relationship exists among three median values in the second wet as well. But as far as drawing the conclusion for the about the difference among the three medians of the population, we have to rely upon the interquartile range that is the measure of dispersion here in this scenario. Therefore, we can easily draw the conclusion that median of all three populations or that sample data leading us to draw the conclusion that median of all three populations differ. In this order, mu2 curve is least, next higher is mu1 curve, and the highest is mu3 curve. But this conclusion we cannot draw over here in this case. So this is how we draw the conclusion about more than two groups, their equalities or inequalities in the context of population, whether it is mean value or the median value. So we cannot draw such conclusion in the second situation easily, comfortably as compared to the first one. Okay, so this is how we apply the concept of analysis of variance regarding measure of central tendencies for the entire population for their relationships. We are relying not only upon the sample findings, whether this is mean or the median, rather we are relying upon the variabilities. In the first case, upon the standard deviation, in this case, upon the interquartile range. That's all for this session.